Okay, we will see about SR flip flop. SR stands for set reset flip flop. Set reset flip flop. So the basic circuit of this SR is like this. I have our NOR gate. I have one more NOR gate. I am marking this as R, this as S. I am giving a feedback like this. Okay. So for this SR flip flop, we have a truth table like this. That is SR output. Output is Q and the other one is Q bar. So a flip flop is a bistable multi-vibrator. Bistable multi-vibrator which has two stable states as 1 and 0. And in the case of SR, if S is 1 and R is made 0, then the output becomes set independent of the previous conditions. നേരത്തെ Q എന്തായിരുന്നു 1 ആയാലും 0 ആയാലും if the S is made 1 and R is made 0, then the output will become 1. Output 1 എന്ന് പറയുമ്പോൾ Q becomes 1 and so Q bar becomes 0. S is 0 and R is 1. S 0 യും R 1 വന്ന സമയത്ത് the output becomes 0. So R stands for reset. So if R is active, the output becomes 0. And if both inputs are 0 0, if both inputs are 0 0, the speciality of the output is that it is not changed. It does not change. If the previous value was 1 for the output, then it continues as 1. And if the previous value was 0 for at the output, then it continues as 0. And for 1 1, S and R made 1. This cannot be given for a SR flip flop since it loses the property. So we call it as forbidden condition. So when S and R are made as 1, Q and Q bar becomes 1. It is not correct since if Q is 1, then Q bar will be 0. So if I am making 1 and 1 for SR, this flip flop loses its property, and so we say that 1 1 cannot be applied to a SR flip flop. So the condition is called a forbidden condition. Okay, so 1 1 is not a valid input for the SR, and it is the drawback of the SR flip flop. As an example, assume that the output was 0 previously, then this will be 1, and I am using this example. S is made 1, R is made 0. S is made 1, R is made 0. So this 0 comes here, and so this is 0, this is 1, 1 0, NOR gate. NOR gate means for OR gate it is 1, so NOR gate it will be 0. So output is 0 here. This 0 is coupled towards here. 0 0 for NOR gate. 0 0 for OR gate it is 0, and so for NOR gate it will be 1. This one is again coupled here. So this is 1 now. 1 and 1. 1 and 1. For OR gate it is 1, so for NOR gate it is 0. And so the output is now become stable. And after these feedbacks, we have to follow the paths till the output becomes a stable state. So this is 1 0 now. So S is 1, R is 0, means the output is now 1, and the Q bar is now 0. So by likewise you can check all the conditions, all the different conditions R0, S0, then R1, S1, R1, S0, etc. While verification, we can see that while giving 1, 1, the flip-flop loses its property, and this condition is called the forbidden condition of SR flip-flop, and this is not allowed in this SR flip-flop because it loses the property of flip-flop. So this is the basic diagram of SR flip-flop. I am drawing one more diagram for SR flip-flop using another gate, a NAND gate. You can create SR flip-flop using different gates. So this is a flip-flop of NAND gate. That of NAND gate. This is Q, this is Q bar. So this input will be S bar and R bar. S bar and R bar indicates that this input becomes active when an active low comes in. So the property of this S works when S0 comes in. We denote it as S bar. S bar now 0 set property work here. SR set property works when this input becomes active, that is S bar becomes 0. അതുപോലെ R bar R bar means R bar is activated when S0 comes in. Okay, so a flip-flop can be, SR flip-flop can be made using NAND gates, NOR gates, or inverted OR gates, inverted AND gates, etc. So all these gates can be used for creating SR flip-flops, and two of them is drawn as a reference. Okay.